Right, this is a moments question and balanced forces, so everything's static. And what we need to do is we need to just have a look at our turning forces on this. Let's put these in. We have a girder with a weight of 200. We have a man with a weight of 80g. Let's put those on. So we've got a weight here of 200g. And we've got 80g here. And we have two reaction forces. One at. Let's call that one R. Let's call that one Q. We need to find out the reaction force at C here. Best thing to do would be, I think, to take moments about this point. If we take moments about this point, then we don't have to worry about this force because there's no turning force of Q around this point. We need our distances, of course, and a 12-metre girder, which I think makes this distance here. It's a bit of a wobbly line. This distance here, I think, makes 4 metres. Here we've got 2 metres, and then we've got 2 metres there as well. So let's have a look at moments around D. Moments around D then. Distance times force plus distance 6 times force 80. And that equals the turning force in the opposite direction, which is a distance of 8 and a force of R, which we are going to find out hopefully. Put all this together. Quick calculation there. We have 1280 times G, 9.8, divided by 8, and there's our answer. 1568, 1570, if we were to give to 3 significant figures, and that would be newtons. So moments around about Q was the way to look at that one, nice and easy. Moving on then, second part of this question. We move one of these supports, and what we now have is we now have the weight of the girder, the weight of the man, and we have 2 reaction forces, one here, one here. Reaction forces, it tells us, and this is important, are now equal, so let's call them both R. Still have our 200G and our 80G as the weights there. Magnitude of the reaction support at X, which of course is the same as the one at C. Now rather than take moments, what I can see is that the forces going upwards to R must balance all the forces going downwards, which is 200 plus the 80G. This tells me that R must be 140G. So the reaction force, if I do a quick calculation there, is going to be 140 multiplied by 9.8, 1372 newtons, 1370 if I was to 3 significant figures, 1372 newtons. Okay, now the value of X, this distance, as soon as it's a distance, we've got to take moments, I think. We can take them anywhere we want. We could take them about the ends of the rod, we could take them about the supports, we could take them in the middle if we wanted. Possibly the nicest thing to do here would be to take them so that we lose one of these turning forces. I think I'm going to take the moments around C. That way I don't need to worry about one of those turning forces. So moments around point C here. Distance times force, 2 times 80G, plus distance here, that is what is that? 4, I think, times 200 g. And they balance against this turning force that goes in the opposite direction. Length of 10 minus the x, so the distance is 10 minus the x, multiplied by the r, which I found out to be 1372. All I've got to do now is turn all this around. So what have I got? Ten minus 6.86. I think that gives me x to be 3.86, so that's 3.14, very pi-like. So 3.14 is my value of x, 3 meters 14 centimeters. And that is my value for x. Done.